Morning, everybody. I have to admit that I almost had a panic attack in the front. I lost my brief this morning, just now, but we got it back. So I seem a little off for a few minutes, that's why. All right, so what we're going to be talking about this morning is data science support to CEMA. We're going to do a high-level coverage of what data science is. We'll talk about artificial intelligence, machine learning, deep learning. We'll talk a little bit about data structures. We're going to look at the machine learning types and what they're used for. We'll look at some data set dynamics. We'll talk about some tools and some nuances between CPUs and GPUs. And then we'll get into some specifics about how data science and these features can actually help in the specific areas within CEMA, cybersecurity, EW, a little bit about spectrum management. How many of you have worked with machine learning and deep learning, artificial intelligence? One or two? All right. So artificial intelligence, everybody's hearing this term nowadays, right? We've been hearing it for a couple years, but it's ramping up more and more. You go into places and you're like, I need a data scientist to get in here and do some AI for us, right? It's going to solve our problem. Well, AI, right, is right now in the position to help us do some things like, predictive analysis, and help us make decisions from information, from large amounts of data that we're getting in, and then to assist operators in different places, whether you're an Intel analyst, whether you're EW type, whether you're a doctor, or whoever it might be, right? This AI is supposed to be helping us. The one thing that a lot of people are confused about when we teach this all the time is they think it's in and of itself is the whole area. AI is the whole thing. What they don't realize is really that machine learning and deep learning are subsets of that. And you kind of need that deep learning and machine learning prior to implementing and deploying AI someplace. One of the things our misunderstanding is that AI right now can then learn simultaneously and make decisions on the fly. And it's not necessarily the case, and nor do we want it to be. If you take into consideration, we were talking yesterday in one of the other sessions about compute power at the edge. NVIDIA and a bunch of other companies are working to push compute power to the front end, so that autonomous vehicles that have AI that are self-driving, right, are not learning at the point of decision making, but they've learned prior to, so they can make a proper decision, right? That takes a lot of pre-planning and a lot of data before it gets to that point that it can make those decisions. So there's a pretty big tail that comes along with employing and deploying and operating AI. Machine learning, right, is a subset of artificial intelligence. And this is where a bulk of work that is taking place right now. You hear a lot more of, the machine learning folks in the room, right? I don't want to say in this room or anything, but we have a lot more discussions about machine learning nowadays when we're talking about data science. Data scientists, right? How many of you have asked for a data scientist to help you with your projects? Quite a few, right? That seems to be like the recurring trend. The hot topic is like, I need a data scientist in here now to help us do something, right? Well, they're the ones that are building out these pieces, and the dynamics of what a data scientist is, right, is still debatable, right? There's a big discussion that goes around those pieces. But they're the ones that are looking at bringing in data, grooming the data, and we're going to talk about the machine learning process a little bit more in depth and point out specific areas here in a second. But this is really where a bulk of work is being done in the AI world right now, right? To help us move things forward, to train the AI to be able to do those decision-making pieces that we want it to do to assist us in our operations, right? And in our planning, and whatever it might be you're employing the AI in, right? It's a higher level of data analytics. Now, when we talk and when we teach data science, a lot of times we get into, and it sounds a really heavy load about just high data analytics, big data analytics, right? There's a small change, though, to a data analyst when you start adding in the machine learning functions, the deep learning functions. We really have to have a little bit higher understanding of mathematics, right, to be able to do those things. It doesn't necessarily mean that a data scientist has to be a mathematician, but data science, machine learning is very heavy on that piece, right? And that's really where we start making the differentiation between a really smart person making business decisions with data, right, through spreadsheets and quad charts and all the other things that we use, heat maps and all those other pieces. But starting to employ and asking the machine to help us in an automated fashion and applying these algorithms to be able to do those things. And we'll talk a little bit about the differences or the different aspects of data processing with machine learning as we go through a little bit more. It is pretty heavy in statistics, but it's not the only thing. Algorithms, the algorithmic choices we make in the machine learning and deep learning phase will then impact, the AI piece that we're looking at and how it processes. Deep learning. The difference between deep learning and machine learning is a little bit more nuanced than machine learning AI, right? So the deep learning process is a way that the machine then takes very limited feature sets of an object, let's just call it an object or something, and then we'll do an iterative cycle of trying to determine what it is, right? As opposed to just straight clustering or some other function within machine learning. It's actually going through and attempting to identify those pieces. How many of you have seen the IBM commercial where they're identifying snow leopards on the side of the Himalayas? Anybody seen those? A couple people, right? That, they make it sound really easy at first, but it is a lot of time. To identify that cat, they started out probably with a couple images of stick figures of what a cat looked like, right? And then built upon it. And as they could identify certain specific attributes about a cat from a 1,000 different angles, right? A photo is being fed into that deep learning algorithm so they continue to hone and refine those pieces out. Now, some people ask, they're like, well, what's the difference between the deep learning piece that you're talking about and identification of objects, such as a snow leopard on the side of a mountain or something else in a crowd, or an individual or an object in a crowd, as opposed to facial recognition? Well, facial recognition, right, is just a snapshot of the features of your face and puts it in and it stores it and it takes a measurement and it can check those measurements against your face or somebody else's face. Being able to specifically identify an unknown object amongst a background of interference, we'll say, is even more difficult to do, especially when it doesn't have a clear way to measure specific attributes about a face, right? So there's a couple different things to pull it out there. They have neural networks, deep belief systems, deep belief networks to be able to build pieces out and drive information. And then multiple layers, right, progressively higher learning. Now, there are a lot of similances in deep learning and machine learning, but the machine learning cycle, right, and we're going to focus on this pretty heavy here. There are, data science and the implementation of AI, ML, and DL, right, is really process-driven. We have to kind of follow this through and understand each stage of this to really be able to go, okay, this is what this takes. A lot of, I go into management places or trying to help somebody with anything, and they're like, I want a data scientist in here to solve my problem right now, right, as opposed to a data analyst. They don't really understand the data science process in itself or the machine learning process in itself, right? It's not it's going to be done tomorrow thing, or it's not going to be done in a week type of thing. There are some pieces we can do to get to a certain understanding of the data and a certain understanding of the processes that are going to take place, but understanding each one of these is really key key concept into, do you really need that data scientist? And what is that data scientist, and what is the data science going to do for you as you move through your project or move through your needs to get to where you want it to go, right? And understanding it will help make those determinations on what level of efforts, what level of resources that you're going to need. And we've kind of broken it down into 4 basic areas: the project design, project preparation, model fitting, and inference and deployment. Now, this is specific to machine learning, and there's some nuances between deep learning and also development and deployment of the AI models that we build out. And again, it's also a little bit more in depth than the overall data science process, but I'll kind of point out some of these things as we go through. So in the project phase, this is where we're sitting down, and a data scientist, your analyst, or anybody else who's going to be developing these pieces out for you or working on your ML in this cycle, right? We'll need to sit down with all the stakeholders, the management, the leadership, the data engineers, whoever else is on the team, and everybody sit down and really understand what the desired output, right, is going to be. There could be any number of wants, but being able to make a determination and understand that at the end of the cycle, what's delivered back to you or delivered back to the customer, it's going to be, I don't want to say spot on, but it's going to be as close to possible as what they want. A lot of times people just go do data science, go do machine learning, and they get back something and they're like, this is not what I wanted at all, right? Or they get back the answer that the machine learning or deep learning is given to them, and it's not what they expected, and they're not happy, right? So having those desired outputs and understanding those going through. Target, the target data identification, understanding where the data is coming from, being able to clearly define those and give those to the data science folks working on the team. I don't know how many times I've been, aside from being handed a large set of data and not having any description or any understanding where it comes from, and just been like, make sense of this for me, right? The other piece to it is you get halfway through the project and somebody else brings you another set of data and be like, oh yeah, we forgot to give you this, right? And expose that data to you from the very beginning. So you need to make sure you understand those pieces and that everybody understands where it's coming from, and make sure that it's going to be a continuous feeding, right, of the data if possible, how it was collected, any biases that might normally be associated with it, right? And going through that information to understand really what's going on. So as we make these next few stages, when we start doing model determination and looking at what features we're going to pull from the data, that it makes it a lot more efficient when we get deeper into the whole process, right? We have model selection, and this isn't necessarily going to be the one that's going to be used throughout the entire cycle. You might pick out a few of them. The data scientists will make a determination on what they think they're going to be able to use. And then they'll also have to make a determination on if there's a new algorithm or there's an adjustment to the algorithm or model that's going to need to be adjusted in that whole process, and going back through it. It's also not set in stone, so this is not a continuous loop. This is an iterative process that will run, kind of not in parallel, but we might do a model selection, make a determination, make a tweak to it, get more data, have to make another tweak to it. So it's going to be internally iterative in cycles, right? Ontology engineering and understanding what the feature sets are going to be. One of the biggest problems or one of the biggest challenges in the data science process, especially in machine learning or anything else, is going to be your data, right? We're looking at thousands, millions, hundreds of millions, trillions of points of data, right, being collected in, and it depends on what type of data we're looking at. When we start talking about the different areas like cybersecurity, implementation for data science within cyber or within electronic warfare, right, we're looking at massive amounts of data. I used in my talk yesterday the example of Twitter. Right? If we were getting Twitter information, we were looking at that, we were trying to identify, doing machine learning and identify clusters of individuals that use specific devices or something, you would be looking at trillions of points of data being generated on a daily basis. So how do you sample that? How do you get that information in? What's the population size of the data that's being generated, the data that you want to use? What's the population of, if you think about electronic warfare, right? What's the saturation of signals in the environment that you're going to be collecting information off of and putting into these places to be able to do these things? And also, not just that, but what's the appropriate sample size of the population? And that's a whole different debate, discussion in and of itself, is population versus sample sizes for training and testing models, right? Because we'll talk about fitting here in just a few minutes. Feature engineering, data labeling, right? These are very important pieces because a lot of times when we get data in, we're going to be either missing data or we're going to need to create a new data point or a new feature about the objects that we're going to be using to move through the machine learning process and through the data science cycle so that we can make the determination on what models we need and what we can use. We might make a determination that a model needs a specific feature to be able to work properly, and we might have to actually engineer that feature for that from the data. Also, we'll have lots of incomplete data that we're going to have to handle, either through imputation or just excluding that data point from it, or putting in notional data to be able to make up something for the object put into there. Each one of those has its own little nuances with it, and own risks and rewards as well. So the data scientists will be able to help work through those pieces. And again, this is going to be, not a one and done type thing. As we move further into the process and we continue it and we deploy it, it's going to need to be continuously reviewed and monitored and understood so that when we deploy the machine learning models, or we deploy the AI, right, that it's going to be continuously updated and managed and outputting the things that we want to do. When I've just said that, there's one thing that needs to be made clear as well is when we deploy AI or we're looking to add AI into something that we're doing, it's not a one and done type of thing. It's not I can build this AI model or deploy this AI function within my environment and I don't need to do anything else with it. It's a continuous feeding and care of that AI through either machine learning or deep learning or some of the process to feed in that AI to be able to learn it. That's why we're looking at compute power on the edge again, right, to be able to move this deep learning, machine learning processing out to the front end where AI is working for us, where autonomous vehicles are working for us, or wherever it might be, so that it can collect data that's in those environments, do this machine learning and deep learning in those environments to be able to add and then retrain and re-inform the artificial intelligence within those environments so that they can perform the way we expect them to do, right? We don't want the AI, again, not being able to make determinations and make decisions for us in a coherent manner if it doesn't have the knowledge. Which is, I think somebody yesterday was asked, at what point do we expect AI to become self-aware and self-determining, right? I don't know if we ever get to that point in the near future. It may in the distant future, but that makes the determination between humans and AI is we can learn immediately and make determinations based off all the information we have, and we can also make determinations based off of other people and other things in the environment that are around us in near real time. AI, right, can only do it to a certain extent. And then when we're looking at and pointing that in places where we're going to be doing or implanting it into areas to help people where there's life and death situations, you don't want it to be unprepared for everything with all the data. So being able to add that information in, whether it's locally or whether it's globally, will play a big part. The model fitting stage is where we actually get into, we pick the models, we pick what we think we're going to be using. We're going to run a couple of them simultaneously probably, or test them. I know in my process what I do is I'll pick 4 or 5 algorithms, take the sample sizes or take the test sets, and run them all together and then compare them and do some comparative analytics between those to see which one's performing best for the data that I have and for the outcome I'm expecting. So then I can make the determination on what it needs to be, what I need to continue with and move on. If the model is failing, if all the models are failing, then I would have to go back in with another team member or somebody else to adjust the algorithms that we're using and taking a look at, do we need to adjust those algorithms? Do we need to create a new algorithm that's going to help us process this? Or do we need to go back in and look at the data to see to make sure if there's another point or another feature that we need to help the models then make a better determination and output for us before we deploy it to get it in there. Right? There is a cloud architecting, right, is one of the areas in this. We're going to talk a little bit more about GPU versus CPU in a few minutes, but not all the time will you have to deploy it into the cloud, right? It just depends on what you're using and what you're expecting it to do and what environment you're going to be in. If it's going to be something large scale, if you're looking at deploying AI, or looking at deploy some sort of machine learning algorithm out into the environment, you will be looking at having to put it into the cloud or put it into some sort of architecture. Again, the buzzword is compute at the edge, right? Edge computing. So moving that out to the front end so you can do those pieces if need be. Once we have the model selected and we have the data trained, or we have the model trained and fit properly, then we can start looking at the predictions it's making for us, making sure that it's working as we expected. We'll bring the stakeholders back in, or you should be coming back into it at that point, and looking and helping the data scientists make those determinations. I will say in the data science process, one of the key fundamentals that we push all the time is communication. I don't know how many times I've seen a customer come in and say, hey, I need this done. The data scientist takes part of the data, goes off, and 6 months later comes back and is like, hey, I made something for you. And either the customer is completely unhappy and the mission is not where it needs to be at, or at some point earlier in that 6 months, they made a determination about something that was really important and relevant. And if they would have known at that point, they could have done something else about it. So continuous communications with the team, with the data science, with the project leads, with management, to understand the expectations and to get feedback on it, so that when the data scientists get ready to deploy this and put this out forward, right, in whatever environment you're going to be using it in, it's going to work the way you want it to work. We have post-processing visualizations, right? In the beginning stages, the determination of the expected outcomes will also influence this step, right? Is what is expected, what is the expected output from the whole process. Once we have everything else engineered, once we have the entire environment set, and it's doing our predictive analysis, or is doing the output from the machine learning, the deep learning, right, and the AI is working the way we expect it to do, what is it that you want to be delivered? Is it a self-driving autonomous vehicle? Is it some sort of spectrum analysis output so you can see a chart of whatever it might be? Is it heuristic rules for cyber threat detection, right, to be able to go through and identify those things and assist NOC operators or SOC operators in managing volumes of alerts, right? So those have to be determined at the very beginning as well to kind of shape where it's going, right? And then operational deployment, actually putting it out and putting it in use and getting it in the hands, getting the output into some place. Once we have that, we're then going to go into a maintenance mode, right? It's going to be a continuous cycle. Has the data changed? Do we have another feature that we can add back into it? Do we need to select another model and then continue outputting at a higher precision of information, right? Do we have a higher precision of AI actions that we wanted to do, right? So it's going to go into that. Again, it's not a one and done thing. I have a set of data, I do this prediction, I put it out there, and I just let it go for months and years on end without any other further tweaking or maintenance of it, right? Anybody have any questions so far? So in data science and data structures, right, in machine learning and deep learning, it will have a very huge impact on how we do specific things and how we will make determinations on model selections, and also what we can and can't do, and importing it in, or not importing it, but applying AI into that area. Two basic data structures, right? Unstructured data and structured data. The easiest way to think of it again would be structured data. We'll think of tables of data, a spreadsheet. We have features in it. It would be like numbers, dates, objects, right? Strings, those types of things. Unstructured data is going to be things like text documents and just big spills of information, right? That don't have any type of structure to it. That we will then have to either make a determination on building some features out of that, right? So we can make some determinations on what it is and what algorithms we can use, and then do the deep learning and machine learning processes to then inform the AI, right? Images, videos, sound, those types of things we think of being unstructured data. When we do the deep learning, when we talked about the deep learning example of identifying snow leopards, that's using unstructured data. It's looking at an image, making some feature determinations on whether or not it's a leg or a head or a back or a tail or something, right? And as it builds out those things, then it can start adding and determining what those features are. It can say, oh, now I know that that's a tail, right? And we can start building those pieces out inside there. Structured data does have form. Again, it's going to be like numbers and integers and different things. The little Gartner information there is most organizations, most places have about an 80-20 split, right? 80% of the data that you have or are looking at or wanting to process is going to be unstructured data, and the other 20% is going to be structured data. I don't have it on here, and we won't really talk about it too much in this briefing and everything else, but one of the things you also have to be aware of is what we call dark data. Who's familiar with dark data? Anybody ever heard the term dark data? No dark data? All right. Dark web, but no dark data. So dark data is all the data that you have and you've pulled in that you don't normally utilize. So if we collected a sample, or we collected an object, let's say a data object, and we're using, let's just say it's on a human. We'll take features of a human, and we're trying to make a determination between people, and we're only using height and weight to make determinations between male and females. Well, there's all these other features about those objects that we could use, but we may not use, that sit there. There are some key considerations we need to make sure of when we're talking about that dark data is can we pull one of those features, right? Can we utilize it properly to help us make a better determination between those objects? So we're trying to make those determinations. And also the resources that we're expending to do this, right? Even though we're not using it, we're still storing the data. We still have to maintain the data. We still have to protect all that data. And the more data that we have, right, the more it costs us, both in those resources and times and efforts and everything else. If we don't need it, right, then we don't need to store it. If we don't ever look at it, right, and you're data scientists, and you really should be pushing your data scientists in, and also your data analysts that are looking into this, to be able to expose to you, expose to leadership and anybody else in the process what that dark data is, right? So you can be like, oh, well, I have this piece here. In the composition of a data scientist, there's kind of like three key areas that we kind of focus in and hone in on. That's for skill sets, that's a mathematician, a computer scientist, and a domain expert. The domain expert in that kind of like three skill set area is going to be the one that understands what the data is and what we're trying to do with that data, whatever field it is, like whether it's a cybersecurity expert or it's a health professional or it's an EW operator, right? That person needs to understand what that is, or what the data is, what the domain is, so they can make a determination of, oh, these are the key features about the objects that we could use. Right? Structured data, less storage. Management will be happy about that. It costs less money to store it, right? The unstructured data obviously is going to cost more money. It's easier to manage structured data than it is unstructured data. We can actually put some protections on it, cell level protections if we're trying to pull information out depending on the environment we're in. We're in a classified environment or unclassified environment. We can do some things with it as opposed to locking down the unstructured data and not being able to do those pieces. The types of machine learning, there are two basic types, right? Supervised and unsupervised. The unsupervised learning, when we have those pieces, when we have large data sets, they're usually in unstructured formats, right? Unstructured data. That's where we'll use unsupervised learning or even some semi-supervised learning, right? To be able to feed data into it, feed that unstructured data into it, use these algorithms to be able to do some clustering and make determinations and feature identification, right? I can pop information into it, and it should be able to pull out and be like, well, I found these things. It won't tell us what those things are necessarily, but it will tell us, hey, there are some like objects and like features within this data set that we can start seeing the objects cluster together. And then we can go back in as a data scientist or the data analyst and look at it and say, okay, oh, I know what that piece is. That's hair color, right? That's individuals. Those are males, and this is what this piece is, or whatever it might be, right? Supervised learning, right, is where we actually know in the structured data, right, what we want it to do. We can take and split out test sets, right, take a sample size of the population, split that out, and have a training set of data that we're going to run through the algorithm so it can learn what it is that we're trying to do, either classification, right, or some clustering with it, right, or do some regression analysis, so we can do some predictive analysis with it and see, right. It is probably, you'll hear it most often in the machine learning and deep learning process of it going through, and we spend a lot of time in that supervised learning state, developing out those features and doing those other things. The unsupervised learning, the way I kind of employ it in my processes is I get data in, I'll run it through an unsupervised model first, right, to kind of see what all is in there, and then start making some other determinations and moving out, and it will help assist me in making some supervised. There is that, I mentioned like a semi-supervised, right? I may know some key features about it, but I'll feed that into the unsupervised model so that it can help it make some determinations of what it might possibly be, right? Any questions? All right. The model selection and training section here, this is a very big, very key point in the machine learning and deep learning process, right? What we're looking for in the model selection phase, and it is really influenced by, again, that population size or the sample set of data that we have from the overall population, and making a determination on what we want to train our model on, and having enough information then to be able to test it against to make sure that it's trained properly. If we have a model that's underfit, it's not going to make the determinations that we want it to make. It's just going to think of it as we dump data into a model and we train it, and it gives us a scatter plot where nothing is clustered, right? We can't make any determinations about what's there. We can't make any determinations. We can't do any predictive analysis with it. The AI can't do anything, right? So it's not able to do that because we weren't able to train it either with enough data, or the feature sets within the data were not refined enough to be able to help it make a determination. The overfit model is where it makes it so that again, everything looks to be the same. There's no division between pieces. There's no separation in clustering or in anything else. And it's either too tight of a fit to the data and unable to make those pieces. What we're looking for really falls in that Goldilocks zone. It won't ever be, I try to get this across to a lot of people, is it won't ever be 100%. We'll still need people, and that's where we get into also when does AI become self-aware, right? It will still need a person, it will still need a human to review it at some point to be able to say, okay, I'm good with that. It also is where we make that determination in the beginning phases on what we're expecting it to do. Is this to help us purchase enough milk to get out the troops, right? What's our threshold for error in that? Can troops on a ship live without milk, right, for 5 days? Yeah, they can live without milk. If it's making a determination that's going to be critical to saving a life, what's your threshold on variance in its predictive accuracy? We don't want that to be a 50-50 split, right? A roll of the dice. We want it to be as accurate as possible. But there's always going to be a slim chance that it's going to be inaccurate at some point, right? Whether that's at some point the data changes and we didn't catch it, or something, an anomaly occurs where it throws off, or we add something into the environment that it was not able to handle in its predictions, in its actions. Again, I use like the autonomous vehicles moving into an area, right? We can train it what weather to expect in certain areas, but until it actually gets in and sees exactly what's happening in the environment, it won't know how to handle that, right? You think about a rainstorm, a car moving into a storm. There's a light shower and there's a deluge, right? There's a derecho. How does that car handle that? It needs to know before it gets into the area that it's occurring, so that environmental variable doesn't affect how it operates, right? And then again, that's going to be a critical decision to make for either the person in the vehicle or people around the vehicle that are operating. So, but we still have to understand that it's not going to be 100% accurate all the time. The way we get to this, again, is through training models, right? There will be, again, an identification of the population of data, then determining the appropriate sample size from that data that we need to be able to make determinations, and then from that sample size, being able to make a determination on what the appropriate test set or training set of data will be, and then the amount of data we need to test against. Data set dynamics, again, we're talking about the sample size versus population size. Precision and margin of error, which we just covered. Data features, again, we kind of touched on that really quickly. Time and resources is a big one, right? So we need to know how long we have to be able to make some of these determinations. How long is it going to take to get enough data to make those determinations, right? Once we get it into the field or we get it into production, right, are we going to be able to continue that, right? Is it going to be cost effective? Is it deep learning? Is it AI? How are we deploying it? Right? And again, the impact we were just talking about. What's the impact going to be? Again, is it going to be purchasing supplies? You're doing predictive analytics to make maintenance requirements. Is that maintenance prediction going to be something that's critical to life, right? So adjusting those thresholds based off the impact that it's going to be driving. So the tools of the trade, there's a lot you'll hear the data scientists talk about. You'll hear quite a bit of it. PyTorch, scikit-learn. I use really quickly on my laptop, I use Jupyter Notebooks. We use Google Colab, RapidMiner, NVIDIA's platform. If you haven't, I would suggest, most people think of NVIDIA as just a gaming company, right? The graphics cards, but I will ask you after this, go and check out NVIDIA's recent conference and look at some of the things they're doing with GPUs, digital twinning, predictive analysis. It is really driving a lot of AI. They have the NVIDIA Tesla, and Tesla's actually using their processor GPUs in their vehicles, right, to do the autonomous driving. Really good training and really good equipment, right? As we kind of get into the CPU versus GPU side, I can do some initial ML and DL on a regular laptop, right? Using Jupyter Notebooks, using Google Colab, using some other pieces, pulling in like TensorFlow and doing some other neural network processing on my CPU. But as we move into larger data sets and we're looking at really deploying this, we really should be looking at utilizing GPUs. Those GPUs really are better at crunching numbers and handling higher volumes of data and throughput to be able to make some of these determinations, right? And again, that will be determinative based off of what your expected outcomes are going to be, right? What you're expecting to be able to do afterwards. Not advocating that everybody have to go out and buy, $150,000, piece of GPU equipment to put in their data center to do machine learning, but it is cool. But you can do some initial things with the CPU and just be aware that you might need to move over to the GPU environment. Right, data science support, we'll try to get through these really quick. To CEMA, which is what I'm pretty sure everybody really wanted to look at. How can these things help, right? And this will help frame the questions you ask and help determine where we really look at and how we fit machine learning and deep learning into our operations within CEMA, right? So cyber operations, the deep learning and machine learning can help us, and AI can help us do intrusion detection and prediction. Well, also with that, when we talk about anomaly detection and identification, we might not always have all the data we're expecting in the future. If we think about how threats attack our systems, right? We have different levels, different skill levels. We have, nation states and everybody else who are really skilled at it, and they're really patient, and they might take their time on doing something. So we can see points coming in over a longer period of time and be able to do some predictive analysis and be like, we think it's going to go to point A and it's going to do this, so we can go protect that asset, or we can be prepared as it moves further. Other things we're going to be able to just see it rapidly handling, right? And we look at more things like seams and stuff and whatnot to handle that piece, but it can help us do some predictive analysis. We actually have a project I work on, we've worked on several times, looking at attack model, and based off of APT's activity, we associate that with other APTs, and we can do a little predictive analysis, say, oh, they're going to do this next step in the attack model at this level, and go and look, right? That DevSecOps, everybody heard of DevSecOps, right? Iterative deployment of applications and stuff. Well, DataSecOps is also something else that we should be talking about, right? Being able to influence inside of those cyber operations, being able to pull information and protect data, right? Be able to employ and deploy ML and AI and deep learning in a secure manner and protect the data, right? We also have user identity and behavior analytics. It was really cool, where ML can then, an attacker might get your credentials and be able to log into your system, but they're not going to do the same things you're going to do. They're not you, so we use the ML to be able to make a determination on if that's the user that's using the credentials, or if it's somebody else using the user's credentials that shouldn't be, right? To be able to see those and do that piece, right? Associative rules, that's the study of characteristics of existing data, right? That will help us alert automatically on other things as it detects unusual pieces. We know what behavior is in an environment, and we can take some of those rules and some of those behaviors and apply it in the data sets, and then come up with the models to push us through. Electronic warfare, right? One of the things that ML, AI, deep learning can help us do is system validation and verification, right? Is the system that we're seeing, right, in the environment what we expect it to see? I was talking with somebody yesterday, and they were talking about, looking at a system or taking a system and taking a snapshot of the coast, and it looked like, 5,000 ICBMs coming at them, right? And then environment with all the other information in the area, how can they make a determination on what is truly friend or foe, and signal separation inside of there, so it can do some baselining and identification of those signals and help do some predictive analysis before we go into an area to help push it in there. One of the other things, too, we were talking about was equipment identification, and not just equipment identification or hull teching, right, but is also, if we know a system, can we do some predictive analysis to know where other components of that system might be at in the general area? So then we can say, oh, I need to look here for this piece. If I see this signal, this equates to this portion. And then also knowledge management, as well as how do we take actions from other units or other tools or other systems and take the information from it aggregated at the edge to then inform all the operators and all the systems in the area that something is occurring, and we want it to work in a autonomous way so that everything is working together and making decisions better. I think we're right at 10 o'clock. Does anybody have any questions? What's that? I was looking at my clock at 10 o'clock on the hour. Oh, sorry about that. See, I told you I was off because I lost my brief this morning. Any questions? Any discussion points? Was there anything that anybody wanted to see and talk about?
Sure, I got a discussion point. I'm an operations guy, so I look at all this stuff from what kind of use. And really, hearing you talk, the network side, I'm not smart on. So as far as like defensive cyber operations, I will not ask about it. But really, from my experience on a division staff, the things that I was looking for CEMA and especially like EW support was immediate action taken upon detection, queuing of other assets, and also within the CEMA cell of other things that they're going to do once they get the acquisition, integration with the other warfighting functions, which you were kind of talking about. So what do I tell intel, what do I tell ops, what do I tell fires, how do they know that immediately, which gets to a little bit of like how these systems talk to other systems and data visualization so that the actual user of that system who is not a CEMA guy can understand the so what, and then improving situational understanding and commander's appreciation, which also goes to the data visualization and integration so the whole staff knows what's going on. The areas that, if anybody is smart about and would want to talk about, is how we integrate AI and machine learning into our sensor management, both delivered and dynamic. So I know what I want to go get because the commander has determined what we're trying to go get. How do I plan that? And then once I'm actually executing my plan, how do I enable better decisions for the dynamic retasking of assets? Because what we usually see is just a shiny object we get, a lob, and now I'm running everything I have
Right.
down that lob to go find a thing, where it's probably not the smartest use of my assets. It's not actually going to be effective life at that point. And a lot of stressed out humans are going to make some maybe not best decisions. So how do I say, hey, here are 3 options you can do from the machine, and then the user can look. And then using that to get more acquisitions of sensors, optimizing delivery if we're going to, electronically attack or use a physical weapon system to attack something and kill it. But I don't know. As we were talking about discussion, like as a consumer of this information, those are the things I kind of go to.
Yeah, and I think that's what a lot of people are trying to wrap their head around, right? Not just in EW or in cyber. I mean, outside of CEMA, how do we employ these and make our lives easier, right? And we heard before like robots are going to take over human jobs, right? Well, we're going to have humans to help manage those robots. AI is not going to do this. AI is going to be the kind of the same thing. It's how do they assist us in really driving in, because the data science world, the machine learning and AI, while we think of it as we've been talking about it for a couple of decades now, it's still a relatively immature area, right? As far as application and how we move it into environments to help in the EW world. How do we help? How does it help us in the warfighting community? How does it help us in the health community, right? It's really rapidly maturing, but having more people to understand it and being able to bring expertise. And when I was talking about like the 3 areas that a data scientist are composed of, right? The math and the computer science and the domain expertise. That's where we need domain expertise to be able to go, oh, well, this is what it is. Because if you brought a data scientist and a mathematician in and tell them, I want you to solve my EW problem, they're not going to solve it. They're going to give you something that doesn't make sense. They're going to be stuck and frustrated. I've seen it quite a bit, not just in like the EW community, but in like the cyber area. Like, oh, this is going to be my panacea. The commander's like, get a data scientist in here. And the data scientist is like, well, what do you need? He's like, I need a spreadsheet. And the data scientist is like, that's not what a data scientist does, right? We can do something at a much higher level to help you do and make your operators faster. And the true outcome I think we want to get to with all of it is, how do we enable the warfighter to make better decisions, right? To make this determination to assist it. We're looking at things like, how do we in the talk yesterday when we were talking about IoT and ICS things, how do we take all that data and aggregate it to be able to feed it to the warfighter that's on the ground someplace? How do we take that machine learning and deep learning to make determinations on what things are in that environment, right? There are either threats or assistive technologies to be able to help them operate in the areas and really, move forward. But I'm glad you're bringing up those points and really thinking about that, because at the staff level, right, that's really where we need to be having some of these discussions and making the staff level smarter on how to employ data scientists and employ AI and machine learning and deep learning and where they flow into. Question over here. So as data scientists or data science has matured over the past, I would say looking at how we employ it in the defense of cyber or in cyber altogether, right, it's come a long way. I don't think some of the tools and stuff that I've seen and try to employ AI as assistive technology in those environments and stuff, we get hung up on a lot of times it being able to automatically alert or be able to automatically generate a signature based off things. And I think that's really where it's at right now, is being able to do some of those heuristic-based identifications. Really, it's still moving forward pretty rapidly, but the cyber world is still trying to make a determination, just like EW world and just like medical, on what information does it need to be finding. What is AI going to help us do? And, like in critical infrastructure right now, how do we employ AI to be able to determine threats and be able to shut things down? And do we really want the AI shutting things down on a critical infrastructure, or do we want it to take some of their action? And that's really where we're trying to find that piece in at. Sure. Well, that's the key word in the whole thing. They have, but properly is subjective, right? What does that environment look at? And when we look at like ICS environments, when we're trying to model that for protection of critical infrastructure, there are so many different variables that are occurring. We've done assessments of facilities before where they tell us, well, here's my network, here's all my equipment in there. We'll actually go to the site and there'll be 50 other devices in the area that have an impact on the overall network. So again, this is where we try to get individuals and management and technicians and everything else to understand, like when we're talking about employing a DL and ML and AI, they have to be forthcoming with all the cards in the deck and be like, this is everything in my network. This is everything I expect you to see. That doesn't mean that there's not going to be a gotcha at some point, but being able to show everything from the very outset to the data scientists and to the team of data scientists, whatever it might be, this is what we have to be able to do those pieces, to be able to effectively map a network, map the spectrum, right, that we're going to be using to do all those other key components. Did that answer the question? Okay.
Well, how do we define the network as a weapon system and properly specify the expectations of the behavior of the network in such a manner that you can model that behavior expectation using AI?
That is going to be a no. I said that's going to be a no. They haven't. I mean, we've identified if we're talking about military, we've defined the DOTN as a key component of military operations as a weapon system, but there's still, from the defense of cyber operations, still trying to make a determination on who owns what. While component commanders can contract out specific pieces and other agencies and think, I worked at the GFHQ DOTN for a while, and you think of like the DOTN gateways as being the only gateways in the system, and then you find out the Defense Commissary Agency has their own AIPs. You're like, well, that should fall under this, but it doesn't, right? And there's 40 plus other agencies and organizations that don't fall under those DOTN gateways. Well, then how do I How have I properly mapped my network, and how do I properly protect that network when I have this other exposure over here? So it is considered a weapon system, like in my opinion, right? Because we can't move data around, we can't make determinations, we can't communicate, we can't do things over the networks that we're wholly relying on nowadays. Then yes, it is part of the weapon system. And if we can't map it properly because it's still not an autonomous, holistic environment, then no. Yep. Any other questions, discussions?
You talked a lot about the general overview of data science, but one thing I don't think you touched on too much was repertoire modeling itself.
Oh,
So things such as converging adversarial machine learning techniques and how they can impact our models. When you take that into account in your process for designing your model.
well, that should be right up to the very front, right? And I don't know if it's necessarily, it's not really thought of nowadays at the level, because most data scientists are not thinking about that. They're thinking about just doing the cool thing, right? Creating the AI, creating the machine learning, doing the predictive analysis, deep analysis. They don't have that security background to understand those pieces. And I think that's where, like, in domain expertise and DevSecOps and DataSecOps really come into play, and understanding those pieces, and then also getting management and leadership to understand, like, this is now going to become part of that risk fabric, that as we develop these, if we pull a model from someplace, where do we get that model from, right? Was that planted by somebody else, right, knowing that it might be there? Anybody familiar with GitHub? Right, so GitHub, I love GitHub. Everybody familiar with their new program, Copilot? Right, it's AI that is scanning GitHub that will do predictive code to you as operator. It sounds really cool as a coder. It's really horrible as like a coder and a data scientist. Anybody in this room should be like completely skeptical of it, right? But it falls into the same thing. And our adversaries, right, are doing the exact same things we're using from the opposite side. How do I employ AI to defeat EW, AI on the other side of me? How do I employ machine learning to make sure that my new malware is undetected by the latest and greatest system deployed by DISO on the network, right? So we're in, if the cybersecurity war that's going on, right, the cyber war that's going on, it wasn't scary enough. Now we have AI added into it, machine learning, deep learning added into it as well, and they're doing the exact same things and adding those pieces in. And they also have the advantage of not being constrained by what we are constrained by, so they can put forward a lot of different things. Any other questions? There was one in the back. Sorry about that.
So as we start aggregating data all over the battlefield, one of the big concerns is being able to identify that, through tagging and diffusion. How can you leverage a combination of AI to automate that? Because it's way too much.
Yeah, so data, what we really call like data provenance, like being able to trust the data, right? It falls in line with like being able to trust your models and everything else, and pull that information in there. Some organization I've worked with will generate those tags based off where the data comes from, right? Being able to put some sort of identifying feature inside of there, but there's always threats to that as well. So I think that's a really a big problem that we have to kind of really look at and incorporate into the data science process as we move forward. And again, looking at the volumes of data, how do we handle that? And the spectrum ops guys and gals and everything else, how do they handle the flow of that information? And when we generate that data provenance information, that increases the amount of data we have to store, right? So we're really looking at a really big problem, right, that affects the outcome, the AI that we're trying to use it with, but it also affects like a bunch of other resources and stuff. Is it going to limit throughput to the back end to be able to ingest all that data because we added that piece on? And so there's like a lot of little nuances with it, but it is right up there at the top of being able to trust your data, right? Just like you want to be able to trust your models, you want to be able to trust the output of that. So, thanks for asking that question.
Thank you, Steve. Really appreciate it.
Thank you. I appreciate it, guys.